The idea of this lesson is to draw the original function when you're given the gradient function. Okay, so 4 examples. Hopefully by the end of it you'll get the idea, but there'll be plenty of practice anyway. Okay, we'll use the same notation, f of x notation and x notation. So I'm starting with the gradient and I want to draw the original function. It tells me that it starts at the origin. So I'll start with that piece of information. I know in the original function there was a point there. At that point where x equals 0, the slope is 3. Okay, it's a positive value. So as a general guide, we're not going to be able to show the slope of 3 particularly accurately. So we'll just show a positive slope. So positive slope of 3 going through the origin, I'll show that by a positively sloped line. Okay, from there, there'll be another point. Say, let's go over 1 unit. There's a point somewhere here. What's the slope at that point? If I go down on my graph, okay, the slope is still 3. So it's still that same steepness. There'll be another point up here somewhere. What's the slope of that line? Well, looks like it's 3 as well. If I go in the other direction, say at -1, okay, there'll be some point out here with that same slope, and at -2, there'll be some point out here with the same slope. Okay, so by drawing all of those tangent lines, I can now draw my original function. Okay, which will be a linear function. Moving on to example 2, we'll use the same idea, starts at the origin. In some problems it may say starts at 5, so we'll put a 5 there and put the point starting at 5. All these ones are just starting at origin for consistency. So I'll start by putting that point in the origin. I'll look at what's the slope at the origin. It's saying that the slope is 0, because this point is 0, 0. The y coordinate, which is my slope, is 0. Okay, but make sure I'm using the same notation. So in my graph here, I've got a flat point at the origin. Let's see what happens to the right hand side. So it's flat here. As I go across a little bit, my slope is getting positive. So at some point, say here, I'm getting a positive slope. As I go further out, okay, the corresponding point here is an even steeper slope than the other slope. So while I've got this line at a certain angle, I'll draw this one at an even steeper angle. There'll be another point here somewhere. Okay, the slope is even steeper. So we've got some sort of relationship going there. I'll look at the other side of the origin. Okay, I've got a negative slope. So from here, my slope is negative. Okay, the question always here is, well, where does the line go? Is it going to go down here or down here? Well, it needs to be the top one, because that's the only way. Magic. Because that's the only... Where did my line go? Having it going downhill from the top is the only way that this point would eventually get to 0. Okay, because we have a negative slope there. I can't have a negative slope down here and then the point magically get back up to the origin. So I've got a negative slope at this first point. Let's move a bit further over. My slope is becoming more negative. Okay, more of a negative slope. So I better draw this one a bit steeper. OneNote really doesn't like drawing graphs. Take 5, okay, negative slope. Just let me draw these slopes. Okay, and then as we go further out, the slope is becoming really negatively steep. Okay, so it probably came from out there somewhere. So I'll be able to draw the original function. I'll draw it in red just for funsies. It's going to be a quadratic. So remember from our original understanding, quadratic functions go to linear functions when we draw the gradient. Alright, number 3 or number 7, depending on however someone numbered these. Whoa. And again, starting at the origin, my slope function is a quadratic, so I'm expecting some sort of cubic. I'm not sure exactly what it's going to look like, but it'll be a cubic function. So I start from the middle. My initial slope is 1, positive 1, so I'll draw a positive slope and then see what happens either side. So as I increase x, my slope is increasing. Okay, so slope gets steeper. Try and make it a bit better in line. Maybe a little bit less steep. Sweet. Okay, increase x a little bit further. Slope gets even steeper. What about the negative value? My positive slope, go across a little bit, slope's even more positive, so it's a steeper value, can't be there, needs to be down here somewhere for it to be positive and eventually get to that 0, 0 point that we're at. Okay, extend over a little bit further, slope gets even more positive. Okay, so the line I would draw would look something like this for my original function, given my gradient. Okay, and surprise, surprise, this is an x cubed function. Okay, I think it's actually x cubed on 3 plus x, FYI. Finally, we've got this cubic function. So this is an x to the power 3 function. So the original function was probably an x to the power 4 function. But don't want to spoil the surprise for you. Okay, again, starts at origin. Pretty exciting stuff. F dash of x and x starts with a 0 slope, so starts as a flat line. Let's go in the positive direction. So as I increase x, my slope becomes negative. So I've got a situation where the slopes are going down. Okay, increase a little bit more, the slope will get to its most negative value. And then as we go across, the slope's still negative, but not as steep. So starting to flatten out a little bit until it gets to this point where it's completely flat. Is that even in line? Yeah, sure. Okay, from this point where it's flat, what happens? Starts becoming positive again. Okay, becomes positive, and then becomes really positive. Okay, so I can sort of see how this part's going. It's going to continue up positively in that direction. Notice that I put arrows on all these, by the way. Yep, good drills, need arrows. Okay, so I'm sorted with the positive x-axis. What about the negative x-axis? So from the 0, move across a little bit, I've got a positive gradient. So the only way I'd have a positive gradient would be if I came from below, my gradient gets more positive. It gets steeper, then it becomes less positive, until finally it becomes flat. Okay, but actually draw it flat. From there, the slope becomes negative again. Okay, it goes downhill. And then from here, really, really big negative gradients. Okay, so to draw what this looks like, it'll be a function that looks something like this. Okay, ideally probably should have some symmetry. Okay, it should have probably gone down the same height in both of these, but we're human, right? We're just drawing these as best we can. So that's drawing the original function. Should actually rename this given the original, given the gradient. Yeah, that'll be renamed for future generations. Alright, I'm going to go break my computer.